Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to learn algebra. Today is our day number 25. Day number 25. Let's see what we have for today. Just give me 1 second here. I have to make a note of something here. I'm still here. There you go. Day number 25 is what we have. We have to add or subtract like terms. Add and subtract, not or rather. Adding and subtracting like terms is what we are doing right now. So here we go. 1/3 f cubed plus 4/3 f cubed minus 2/3 f cubed. And we simply have to find the sum of it. That's all. Very simple, very straightforward question. Again, I'm still here. I'm taking care of fixing some things in my notes here. So, what do you notice? Since we have f cubed, and we have f cubed, and we have f cubed, since they are the same variable raised to the same power, these are called like terms. And if they are all like terms, they are all like terms. All we have to do is simply add up the exponents. All we have to do is simply add up the exponent. 1/3 plus 4/3 minus 2/3. Another thing that makes it easy for us, another thing that makes our life easy is the fact that the denominator is all the same. It's all 3's. So since they have all the same denominator, we simply add up. Or even if you don't have to make it so complicated, 1/3 and a 4/3 will make it 5/3. 5/3 minus 2/3 should make it 3/3. Oh, which is just 1. So it's just f cubed. How many f cubed? Well, 1 f cubed. We made a big fuss about it yesterday on day number 24. We talked about it. That's it. That's the answer. 1 f cubed. That's it. Let's do one more. Let's do one more. Here's the next problem. 1/3 f cubed plus 4/3 f cubed minus 2/3 f squared. Now what happens? But they're no longer all like terms. Here we have f cubed. Here we have f cubed. But here we do not. This is f squared. F squared cannot be added to f cubed. F squared cannot be added to f cubed. And let me make you understand what that actually means. Okay, pay attention here. Let's say the f is 2. If you have 2 cubed, 2 of them, and if you have another 2 cubed, one of them obviously, since they are not told here, how many 2 cubes do we have? We have 3 2 cubes. 3 2 cubes. Watch what happens. 2 cubed is 8. 8 times 2 is 16. This part, let's put this here. 3 2 cubed. Okay, watch. See? Here we had 2 cubes, and here we had 2 cubed, and we have 2 of them here and 1 of them here, so we have 3 2 cubed. Watch what happens. 2 cubed is 8. 2 cubed is 8. 8 times 2 is 16. 2 cubed is 8, so it's this. 16 plus 8 is, well, we know that 16 plus 10 is 26, so it is 24. Let's see what we get on this side. 2 cubed, which is 8, times 3, 24. Voila, you see? But if instead of 2 cubed and 2 cubed, if this guy was 2 squared, then we could not have done what we just did. You cannot say 2 of 2 cubed and 1 of 2 squared equals 3 of the 2 cubed or 3 of the 2 squared. It would not work. These are different powers. If I ask you 3 raised to 3 and 3 raised to 2, how much is it? Well, That's what it is. It's 3 cubed and 3 squared. You cannot add up the two terms. Think of this, if a happens to equal to 3, this will be a cubed and this will be a squared. A cubed plus a squared is just a cubed plus a squared. You cannot do anything with it. You cannot simplify it. They are unlike terms. They are dissimilar terms. They are not like terms. So what happens here? Let me erase all of this thing then. So here we have f squared and here we have f cubed and f cubed. These two can be added because they are the same variable with the same exponent. So a 1/3 and a 4/3 is just 5/3. So it's 5/3 f cubed minus 2/3 f squared. That's the answer for this particular problem. Let's do one more. What if we had 1/3 f cubed plus 4/3 f squared minus 2/3 f? How do we add them? How does one add these three terms? The question is, how does one add these three terms? To which the answer is, one bloody well does not. One does not add these three terms because these are unlike terms. This is the f cubed. This is the f squared. And this is just an f with the power of 1, f to the first power. These are unlike terms. They cannot be added. You know, it doesn't make sense. For example, let me give you one simple example. If I tell you how much is 2 squared plus 2, in algebra what it means is that when somebody asks a question like this, what they're asking you is, how many 2 squares do you have? Well, you have 1 2 squared. And how many 2's do you have? You have 1 2's. That's it. A squared plus a is just a squared plus a. Now, had this been like this, then we could say that we have 2 squares. Had this been a squared, then a squared plus a squared, we could have said that we have 2a squared. They would have been like terms. Let's do one more. Let's go to the next problem. I'm done with this particular problem. Let's go to the last one. A square x plus 5a square x minus 9a square x plus 5a square x. Well, lucky for us, these are all like terms. A square x, a square x, a square x, and a square x. They are all like terms. Since they are all like terms, all we have to do is simply add up the exponents. Since they are all like terms, similar terms, I can never write terms first time properly. Since they are all like terms, all we have to do is to simply add up the coefficients. Positive 3, positive 5, negative 9, and a positive 5. Well, a positive 5 and a positive 5 is a 10. 10 minus 9 is 1. 1 plus 3 is 4. So the answer here is 4a squared x. That's all. That's all. Let's do one last problem before we call it a day. Let's do one last one. What if we were asked how much is this? 3a squared x plus 5ax squared minus 9a squared x plus 5ax squared. Are these all like terms? No. Here, the second power appeared on a. A squared, a squared, a squared, and a squared. That is no longer the case here. Here we have a square x, we have a square x, But here we have something different. Here we have ax squared, ax squared, ax squared. These four are no longer like terms. These two are like terms, these two are like terms, and these two are like terms. So we simply add up these two. 3 minus the 9 is negative 6a square x. And then, oh, 5 plus 5 is 10. That makes it easy. How the hell did it happen? What do you know? So it's just 10, 5 plus 5 is 10, ax squared. That will be the answer here. That will be the answer in this case. That was the end of our lesson for today. I will see you tomorrow on day number 26. It says here, this schedule that you see here, first 20 days, we evaluated algebraic expressions, and as I've said many times before, if you have watched my videos in this series before, it is imperative, it is important, it is of utmost gravity that you watch this video in the series that it is intended for, if you want to learn algebra the proper way. Don't take the lazy minutes out and start watching videos here and there. If you watch them in sequence, you will get a hell of a lot more out of it. In the first 20 days, we evaluated algebraic expressions. My intention was, in the next 10 days, to do addition and subtraction of like terms. This will have to be changed, this number has to be changed, it will have to be moved up, which is why this says tentative schedule, because I wasn't sure about it. But when the time comes, I'll tell you. I'll see you tomorrow on day number 26, okay? In the meantime, if you wish to get hold of me, you can go to any of these website addresses and send me an email, or you can find my telephone number there, or toll-free number, and give me a call if you wish. Or you can go to keshwaniprep.com and get hold of me from there. Alright? Thanks.